Static friction. The static friction is a force that keeps an object at rest. But if a small amount of force is applied to an object, the static friction has an equal magnitude in the opposite direction. To the coefficient of static friction is assigned the Greek letter mu. The maximum force of static friction is μs times the normal force of an object.
I'm gonna tell you the main key concepts, and for starting, the friction. Friction is a force that holds back the movement of a sliding object. That's it. Friction is just that simple, and you will find friction everywhere that objects come into contact with each other. And the force acts in the opposite direction to the way an object wants to slide. Then we have the kinetics. Kinetics is a branch of classical mechanics that is concerned with the relationship between motion and its causes, specifically forces and torques. Then is statics. Statics is a branch of mechanics that is concerned with the analysis of loads acting on physical systems that do not experience an acceleration, but rather are in a static equilibrium with their environment. When in a static equilibrium, the acceleration of the system is zero, and the system is either at rest or its center of mass moves at constant velocity. Then we have the variables. The independent variables are the weight of the objects we're gonna use and the angles. And the dependent variables is just the velocity as the object falls.
Now, the main objective for this experiment is to measure the coefficient of static friction between two surfaces. For this experiment, we use a foamy material and the different weights of 200 grams, 400 grams, and 600 grams.
To test the friction of the foamy, we're going to perform some different action in order to break the static force between an object and the foamy. We're going to measure the friction between objects of 0.2 kilograms, 0.4 kilograms, and 0.6 kilograms. So we're going to put the foamy over a wood plank and then make some different angles and then observe if the object slides down. We're going to perform it with 10 different angles per object, in total 30 angles.
The results we've got were that in the first angle, that was at 0 degrees, the cell phone that was the object with 200 grams did not slip, the pencil case that was the object with 400 grams did not slip, and the cream that was the object with 600 grams did not slip either. Then we have the second angle that was in 5 degrees. The cell phone did not slip, the pencil case did not slip, and the cream did not slip either. Then we have the third angle that was 9 degrees, and same as the other ones, none of the objects slip. Then we have the fourth angle that was in 15 degrees. The cell phone did not slip, the pencil case did not slip, and the cream did not slip either. Then we have the fifth angle that is in 18 degrees. The cell phone did not slip, the pencil case did not slip, and the cream did not slip either. After that, we have the sixth angle that was in 31 degrees. The cell phone slipped a little, the pencil case not, and the cream slipped completely. Then we have the seventh angle that was in 42 degrees. The cell phone slipped slowly, the pencil case slipped, and the cream slipped completely. Then we have an angle with 45 degrees, which the cell phone slipped, the pencil case a little, and the cream slipped completely. Then we have the ninth angle that was in 75 degrees, where the cell phone slipped completely, the pencil case slipped a little, and the cream slipped completely. And finally, the 10th angle that was in 81 degrees, where the cell phone slipped completely, the pencil case slipped completely, and the cream slipped completely.
For our conclusion, we can determine that with this experiment we can now understand that friction varies depending on certain things, as the material in which this object is sliding, in this case, and the properties of the object that was sliding, as its mass, the material, and the angles. So basically this experiment helps us to understand how friction works.